If two lines are perpendicular lines, then they intersect to form a right angle. I want to see if this statement is a biconditional, and if so, I want to rewrite it as one. This is my original statement, and it appears that my original statement is true because it follows the definition of perpendicular lines. Perpendicular lines intersect to form right angles, so this is true. I need to figure out if it's true the opposite way. So I need to find the converse, which means that I need to switch the hypothesis and the conclusion. So if they, so two lines, intersect to form right angles, then they are perpendicular. And now I got to think about, is this statement true? And I believe it is, because if two lines do form right angles, then they can be defined as perpendicular. So that's also true. Now technically the biconditional statement has the original statement, the inverse, the converse, and the contrapositive all true. So I know the converse is true. Since I know the converse is true, the inverse also has to be true. Since the original statement is true, I know the contrapositive will also be true. So all four statements are true, which means that this statement can be written as a biconditional statement. With the biconditional statement, I lose the if and the then, and I replace them with if and only if. So it looks like this. If two lines are perpendicular, two lines are perpendicular if and only if they intersect to form right angles. And this biconditional statement that I have written, again, an if-then is no longer required, is true forwards and backwards. No matter which way I read it, the statement is true. And that's the important thing with biconditionals. Both conditions are true.